Okay, welcome to my video on doing esters. It's the second or third time I've been using this Wacom pad, so I'm still getting a bit of an idea of how to draw successfully on this. It's a bit difficult. Sorry about all the noise, but I am at home. We're going to look at esters and not so much the creation of it now, but actually the hydrolysis of it. So we'll just go to ethyl ethanoate because it's just a simple one to do. Oh man, I need to get better at this. Bond C dash dash dash. I guess if I take it slowly, that should be alright. Go straight down, straight across, and straight down. Okay, so we're dealing with ethyl ethanoate here. That double bond O there looks terrible. Should clean that up. Alright, let's go to the pen. Take it nice and slowly. One down and one down. No, it's a little bit better. Remembering that when we name this, we name the alcohol side, which is this side here, that is ethanol. And then you do the acid side, which is the ethanoic acid. Now, when we put this reaction together, it's a condensation reaction, because of course, you know, if you've got your ethanol, 1C on OH. I might just rush this a little. That looks crap. And then you've got your carboxylic acid, O bond, and there's your acidic proton, and then that's attached to a C, which is attached to another double bond O, and then bond C and 3 hydrogens. Now normally we would say, or I think I presented in my presentation, that this alcohol group detaches and this proton detaches, and they go away and become H2O, which is why we call it a condensation reaction. But actually, if you watch a video that I'll put up online, you'll find that there's several steps to the Fischer esterification process, and it's a lot more complex than you would have assumed. So I think, like for example, this is going to be a practical for later on. So if you go and watch that video and you do the step-by-step esterification process as part of your introduction, you're probably looking at a pretty high mark. You know, we're talking in the A bands here, because it does involve a little bit of university level chemistry. So I encourage you to go watch the video if you've got time. I mean, especially if we're all hardened from the coronavirus at home, you certainly will have time. Now, when we hydrolyze an ester, which is the opposite of condensation, you break it at this bond here, which is where it where when you go through the several step process, the alcohol attaches to the carboxylic acid, and you stick a water back into the process there, because the it's a hydrolysis reaction. Now, you've got two options with a hydrolysis reaction. You can do it in the presence of a strong acid. Wow, that looks crap. H plus, or you can do it in the presence of a base, OH minus. Now, the products are going to be different, and your ability to draw those products is critical. So in the presence of an acid, in the presence of both of them actually, you're going to get your you're going to get your alcohol, OH, 1, 2, 3, 4, 5, and down here I'll add the ethanol too. Wow, I need to get used to how to draw on this thing, or I need to get it to a decent angle so I can. It's really quite difficult to draw on a PC tablet when you're not very used to it and stare at the screen at the same time. Okay, there's our two ethanols. They're quite happy to exist in an acidic or a basic environment. There's no real problems there. It's all polar stuff. But your products for the carboxylic acid are going to be different. Of course, in acidic conditions, you're going to be able to keep that acidic proton. So the H will be stuck to the O there. You'll have your double bonded O here, and then you'll have your other carbon finishing off the ethanoic acid. But the difference with your base environment there is it's going to be well, man, it's just really tough. You're not going to have that acidic proton there because, of course, when there's a bunch of OH floating around, any proton that can be soaked up will be, and it'll be soaked up to make water, of course. It'll be a neutralization reaction. So you're going to have this here, which is what we call the carboxylate ions. So the functional group, of course, is this baby here, and that's your carboxylate ion, and that's going to be the product in basic conditions. So you've got to make sure that you draw these products out correctly. So if we were to do it easier, it'd be OH. That's certainly a bit easier to draw. And one double bond O bond H. So there's your acidic products. And let's go back to the purple here for the basic. Again, we're just going to draw in our alcohol, OH, and then your product for the carboxylate ion is going to be different because you're going to have an O minus here, and you're going to have your double bond O there. And so that's what you're going to have in basic conditions. Right, hope that makes sense. Thank you.
La 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 la. La 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 la. La 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 la. La 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 la. La la. La la la. La 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 la. La la la. La la. La 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 la. La 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 la. La la. La 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 la